Objective A. Find the greatest common factor GCF of two or more integers or terms. Number one is basically a review of chapter 1 when we are looking for the greatest common factor among different numbers. We have three numbers, 30, 42, and 66. The most common way is doing a tree, but of course for small numbers you could just list out all the factors among all these three different numbers and then check out the greatest common one. But let's do a tree. 30. Put the 30 on the top and then pick a pair of numbers such that when you multiply you get 30. A common choice is probably 3 and 10, but you could also choose other choices like 15 and 2. And then we're going to circle prime numbers. So 3 is a prime number, I'm going to circle that. 10 is not a prime number, so you're going to keep going. That's going to give you 2 and 5. And each of these is a prime number, so you circle them. If you look at the end of the branch, all the branches have a circle at the end, then you know that your tree is complete. So we have our prime factorization for 30, which is 2 times 3 times 5. Next, moving on to 42, so we do the same thing. I'm going to choose 6 and 7 from our multiplication table. Circle 7 because 7 is a prime number. Under 6, you could do 2 and 3. Each of them is a prime number, so circle them. Therefore, 42 has a prime factorization of 2 times 3 times 7. Now moving on to 66. A common way to do 66 will be 6 and 11. 11 is a prime number, circle it. Under 6, we have 2 and 3, and again, each of them is a prime number, so circle them. Therefore, we have our prime factorization for 66, which is 2 times 3 times 11. To find out GCF, you basically look at the prime factorization for each of these numbers, and then highlight the common part. I would say each of them has 2 times 3. That's the common part. Therefore, your GCF for this will be 2 times 3, and that is 6. So 6 is the greatest common factor among 30, 42, and 66. Number 3. For this chapter, however, when we look at GCF, we're not looking at GCF of numerical numbers. We're looking at GCF of algebraic expressions. So you have to check the numerical part, which is usually the coefficient, as well as the variable part. Let's look at number 3. 16x cubed y to the 5th, negative 4y cubed. First, you're going to look at the GCF of the coefficient part. So GCF of 16 and negative 4, these are the coefficient part. If you just look at 16 and 4, GCF will be 4. So you could do a tree like what we did. Some people might say, what if I put negative 4? Well, usually we put GCF as the positive greatest common factor. So I'm going to use 4 instead of negative 4. But I can't say negative 4 is incorrect. But I'm going to use positive 4 as the GCF between those two coefficients. And then you're going to move on to the variable part. When you look at the variable part, I highly recommend that you look at them separately. We have two different variables, right? You have x, you have y. So you're going to take out each of them from each of the expressions and write them out. So the first one, you have x cubed as the variable x. But the second one, you don't have variable x. So you could just write a 1 instead. And then check out these two. What is the greatest common factor? What do they have in common? I would say both of them have 1. Because I could rewrite x cubed as x cubed times 1. Right? So that made them having a common factor of 1. Now we're done with variable x. You're moving on to the other variable, which is y. First one is y to the 5th, and then second one is y to the 3rd. What do they have in common? Well, the first one has 5 y's multiplying together. The second one has 3 y's multiplying together. When you put them together, they both have 3 y's, at least 3 y's multiplying together. So the greatest common factor is y to the 3rd. And then finally, you combine all these three, write your final GCF as the product of all those three things. So 4 times 1 times y to the third, that gives you 4y to the third. So that is the GCF between these two algebraic expressions. All right, moving on to next part, number 5. Most of the time, you don't have to write what I wrote. Those are just your thinking process. It's how you identify the GCFs. Most of the time, you simply just look at the expressions and then check out what they have in common and write down as the GCF. So we're going to use number 5 as an example. Starting with the coefficients. First expression, coefficient is 7. So let's highlight that, choosing a color. This is the coefficient, 7. The second expression, it doesn't have a coefficient if you look at it, but I can put an invisible 1 in front of the expression. Therefore, it has a 1. So GCF between 1 and 7, it's going to be 1. So we don't have any coefficient GCF. It's basically just 1. Moving on to the variable part. The first expression, you have 4x minus 1. The second expression, you have x times 4x minus 1. Apparently, both of them have 4x minus 5. 4x minus 5. Therefore, that is your GCF. So it's going to be 4x minus 5. That's your GCF. So most of the time, we simply just write down the GCF without writing down all those individual parts. That's 1, 3, and 5. Objective B. Factor out the greatest common factor from a polynomial. This requires you to find out the GCF first and then divide the original expression by the GCF and write down what's left. So let's look at number 7 as an example. First, identify the GCF. We have the coefficient, we have variable x, and we have variable y. So you're going to take out GCF from each of them. 24 and 56. If you do a tree, you will find out that the greatest common factor is 8. And then looking at x. The first expression is x. The second is x squared. Both of them have at least one x. So it's going to be x as the GCF. And then you look at the y. Y squared and y. Both of them have at least one y. And that is your GCF. So that's y. And AXY is the GCF between these two expressions. Finally, we're going to take out AXY. So you're going to divide the original expression by AXY. First term is 24xy squared. If you divide it by AXY, let me write next to it, 24xy squared divided by AXY. Cross out the common factors. So a goes into 24 3 times. So that will be a 3 on the top. And then x and x, they cancel out. Y and this square cancel out. You have 2 y's on the top, 1 y on the bottom. So you cancel out 1 y. You have 1 y left on the top. Then you're going to write down what's left. So we will have 3 on the top, y on the top, nothing on the bottom, which is just 1. So it's basically 3y. And therefore, you're going to write 3y inside. For the next term, you do the same thing. 56x squared y over the GCF that you took out, AXY. And then you write down what's left. A goes into 56 7 times. So you have a 7 on the top. And then x and 1x cancel out. So you have 1x left on the top. 1y and 1y cancel out. And finally, you have 7x over 1. That's the result. Therefore, inside, we're going to do plus 7x. It's basically a division process. Dividing polynomial by a monomial. And you can always check whether or not it's correct by distributing AXY into the parentheses, multiply out, and it should give you the original binomial. Moving on to number 9. First, look at the coefficients, 16, 12, and negative 4. they have a greatest common factor of 4. So you could either look at them or you could do a tree. And then look at the variable part. You have w to the 4th, w squared, and w. Apparently, all of them have at least one w, so it's just going to be w. So here you probably know a trick, right? If you have the same variable, you basically take the lowest power, that is your GCF. And then you're going to write down what's left. So here I'm not going to write each individual division out again. Most of the time you're going to do that in your head. First term, 16w to the 4th divided by 4w. You could do 16 divided by 4, that is 4. And then w to the 4th divided by w, that's w to the 3rd. Plus 12 divided by 4, that's 3. W squared divided by w, that's w. And then negative 4 divided by 4, that's negative 1. I'm just going to put a negative sign because coefficient of 1 can be invisible. And then w divided by w, that is also 1. And since none of these are non-1, so I'm just going to put a 1 right here. And that will be our last term. Number 11. Starting with coefficients, we have 4, 7, and 3. If you do a tree, you will find out that the greatest common factor among these three numbers is simply 1. So you don't have to write that, it's just an invisible 1. Then look at the variable part. You have a to the 6th, a to the 4th, and a to the 2nd. Based on our experience, you would take the lowest power, a squared. So that is your GCF. And then you're going to write down what's left. So basically doing a division. 4a to the 6th divided by a squared. First of all, 4 divided by 1 is 4. And then a to the 6th divided by a squared, that's a to the 4th. Second term, negative 7 divided by 1, that's negative 7. A to the 4th divided by a squared, that's a squared. Finally, positive 3 divided by 1, that's positive 3. A squared divided by a squared, that is 1. So it's 3 times 1, which is 3. And that completes our factoring for number 11. Objective C, factor by grouping. Factor by grouping usually involves 4 terms. And what you need to do is you're going to group these 4 terms, put the first 2 terms together, factor GCF, put the last 2 terms together, factor out GCF. Let's look at some examples. Number 13. Number 13, we only have 2 terms. So basically, you're going to find out the GCF between these 2 terms. And I would say it's very easy to see that both of them have m minus 6. And the second one has something similar, which looks like m minus 6, but it's not exactly m minus 6. It's 6 minus n. So these 2 things, what do we call them? We call expressions like this opposite factors. It's like, positive 2 and negative 2, they're opposite factors. M minus 6 and 6 minus m, they're also opposite factors. If they're opposite factors, then you could take out negative 1 and make those 2 factors exactly the same. So what I'm going to do is I'm going to keep the first term, write as m minus 6. I'm not going to change it. But for the second term in the original expression, I'm going to factor out a negative 1. So notice that I already have a negative sign right here. If I factor out negative 1, negative and negative becomes positive. So it's going to become positive in the middle. And then I'm going to copy the m because it's outside. As for the 6 minus m, I'm going to rewrite that as the opposite factor of this, which is m minus 6. So that's basically what I did. I rewrite 6 minus m as its opposite factors by taking out a negative 1. And because we have a negative sign before 6 minus m, negative and negative becomes positive. Next thing, now we are ready to factor. So both of these 2 terms have m minus 6. Then I could take it out and write down what's left. The first term, you have a 5x. And the second term, you have a positive m after we take out m minus 6. So that will be what happened after you take out m minus 6. you will write as something times something. That's basically the idea of factoring. You write in the algebraic expression into a product of different algebraic expressions. Moving on to number 15. Number 15, I would say it's much easier compared to number 13 because both of these have m minus n. They're not opposite factors, they're exactly the same factor. Before we do the factoring out, I'm going to put an invisible one in front of m minus n. Now we are able to factor. If we factor out m minus n, the first term we have a full n left. And the second term, we have a negative 1 left. So you just put them together. Inside the second parentheses, it's the GCF that we took out, which is m minus n. And that completes the factoring for number 15. Sometimes you will have 4 terms, like I said earlier. Like number 17, we have 4 terms. They are not grouped yet. So what you need to do is you're going to group them, put the first 2 terms together, and then put the last 2 terms together. So let's do that. Equals, so I'm going to put the first 2 terms together, add a grouping symbol. And then the last 2 terms, how am I going to group them? Because there's a negative sign. If you look at it, we have a negative sign right here. So what I'm going to do is I'm going to put a plus sign in the middle and then put the last 2 terms together, including the negative sign. Alright, so let me move that parentheses a little bit. So I didn't do anything if you look at the first line. It's the same as the original. The only difference is I add a plus sign in between the first 2 terms and the last 2 terms and add 2 pairs of grouping symbols around the first 2 terms and the last 2 terms. The next thing you need to do is factor out the GCF, just like objective B. Between the first 2 terms, 2 and 10, the GCF is 2. And then w squared and w, the GCF is w. There's no y in the first term, so that completes our GCF. And you're going to write down what's left. The first term, 2w squared divided by 2w, you will have a w left. Second term, 10wy, if you divide it by 2w, it's going to give you positive 5y. So that completes the factoring of the first 2 terms, and we're going to do the same thing for the last 2 terms. Don't copy the plus sign yet, because we're going to take out a negative GCF this time. Looking at the coefficient, you have negative 3. You also have negative 15. The GCF between these two, since both are negative, I'm going to take out a negative GCF, which is negative 3. So usually, what happens is if you have the third term that's negative, like this, you're going to take out a negative GCF. And it doesn't matter if this one is positive or negative. We're also going to do a negative GCF here. Once I take out negative 3, I'm going to check out the variable part. You have wx, you have xy. Both of them have x, so you're going to take out the x. And then that's the GCF. Then you could write down what's left. First term, negative 3wx. If you take out 3x, negative 3x, then you have 1w left, so write a w. Second term, negative 15xy. If you divide it by negative 3x, you're going to get positive 5y. Notice that they are the same. W plus 5y, w plus 5y. That's how you know that you are on the right track. So you could actually cheat a little bit. Once you identify the GCF is negative 3xy, chances are the inside must agree with what you have in the first part, w plus 5y. Therefore, we do factor by grouping. We take out GCF, w plus 5y, and we have 2w from the first, and then negative 3x from the second. Write them inside 2 pairs grouping symbols. That completes our factoring of number 17. Objective D. Solve applied problems involving factoring. Employees paid hourly may earn time and a half for hours worked above 40 hours per week. the regular hourly rate for employees is X dollars. During a particular work, A employees work 40 hours and B employees work 56 hours. What is the total cost of the company payroll for that week, expressed in factored form? So this question is talking about payroll. If you're gonna work in HR in the future, you probably want to think about this. And the company has this pay time and a half for hours worked above 40 hours. So that will apply to the B employees who worked 56 hours. That's more than 40 hours. So I'm gonna deal with the 40 hours first and then deal with the extra hours later. For the A employees who work 40 hours, since you're A of them, so you have A, and I'm gonna multiply this by X. Because the regular rate for employee is X dollars. And then they all worked 40 hours, so you multiply by 40. So that completes the total payroll for those A employees who work 40 hours, 40 AX. And then you're gonna do the same thing for the B employees. They work for 56 hours, but let's just break it down into 40 hours and 16 hours. So I'm gonna break it into 40 plus 16. For the first 40 hours that they worked, it's gonna be the regular pay rate, which is X dollars per hour. So it's gonna be 40 B and X. That will be the payroll for the first 40 hours for those B employees. And then we're gonna deal with the additional 16 hours. The additional 16 hours, their pay rate will be increased. It's gonna be increased and time and a half. So it's basically 3 halves of the original. So what I'm gonna do is first, let's just treat it as regular. You have 16 hours, B employees. Each hour is X dollars per hour, but that's the regular rate. And now we have this time and a half for extra hours. You're gonna multiply this by 3 over 2. How do I get this 3 over 2? It's basically 1 and a half. The 1 is their base pay rate, plus the half, that's the extra for over hours. And if you calculate this, it's gonna give you 3 halves. So that's why I got that 3 halves. Now let's combine this expression and simplify. You have 40 AX plus 40 BX plus, so over here I can divide 2 into 18. There are 8 2's in 16. And then multiply everything on the top. 3 times 8, that's 24. And then you have BX. Now combine like terms. 40 AX plus 64 BX. Since the question wants you to express this in a factor form, I'm going to factor out the GCF between these two terms. First, coefficients, 40 and 64. If you do a tree, you will notice that the GCF is 8. And then look at the variable parts, AX and BX. Both of them have an X. So that is the GCF. And then you write down what's left. So I'm going to divide the original by AX. 40 AX divided by AX, that will give you 5A. Plus 64 BX divided by AX, that will be AB. And that completes number 19. Thanks for watching.